Welcome to Sci Discovery Chronicles. In today's episode, we're embarking on a journey to understand one of the most pressing scientific challenges of our time: climate science. This field is crucial for comprehending the intricate workings of our planet and the changes it's undergoing. So, fasten your seatbelts as we dive into the complex world of Earth's climate system. To begin, let's define what climate science actually is. Unlike weather, which describes short-term atmospheric conditions, climate refers to the long-term average weather patterns in a specific area. Climate science, therefore, is the study of these long-term patterns, their causes, and their effects on our planet and its inhabitants. The history of climate science dates back further than you might think. In the early 19th century, scientists like Joseph Fourier began to understand how Earth's atmosphere trapped heat, leading to what we now call the greenhouse effect. By the late 1800s, Svante Arrhenius had calculated how changes in atmospheric carbon dioxide could alter global temperatures. But what exactly makes up our climate system? It's far more than just the atmosphere. The climate system consists of 5 major components: the atmosphere, hydrosphere, oceans and other water bodies, cryosphere, ice and snow, biosphere, living organisms, and lithosphere, Earth's crust and upper mantle. These components interact in complex ways, creating the climate patterns we observe. Let's break down these components and their roles. The atmosphere. This thin layer of gases surrounding Earth plays a crucial role in regulating temperature and distributing heat and moisture around the globe. It contains greenhouse gases like carbon dioxide and methane, which trap heat and keep our planet warm enough for life. The hydrosphere. Oceans cover about 70% of Earth's surface and play a vital role in climate regulation. They absorb vast amounts of heat and carbon dioxide, acting as a buffer against rapid climate changes. Ocean currents also help distribute heat around the planet. The cryosphere. Ice and snow reflect a significant amount of solar radiation back into space, helping to cool the Earth. As global temperatures rise and ice melts, less solar radiation is reflected, leading to further warming in a feedback loop. The biosphere. Living organisms, particularly plants, play a crucial role in the carbon cycle by absorbing carbon dioxide during photosynthesis. Conversely, when organisms die and decompose, they release carbon back into the atmosphere. The lithosphere. While slower to change, the Earth's crust and upper mantle influence climate through volcanic activity, which can release greenhouse gases, and through the long-term carbon cycle involving rock weathering and formation. These components don't exist in isolation. They constantly interact through various processes and feedback loops. For instance, as the atmosphere warms due to increased greenhouse gases, this leads to melting ice in the cryosphere. The melting ice exposes darker land or water surfaces, which absorb more heat, leading to further warming. This is known as the ice-albedo feedback loop. Now, let's delve into some key concepts in climate science. The greenhouse effect. This natural phenomenon is essential for life on Earth. Greenhouse gases in the atmosphere trap heat, keeping our planet warm. However, human activities have significantly increased the concentration of these gases, enhancing the greenhouse effect and leading to global warming. Carbon cycle. This is the movement of carbon through Earth systems. It involves processes like photosynthesis, respiration, decomposition, and the burning of fossil fuels. Understanding the carbon cycle is crucial for predicting future climate changes. Climate forcings and feedbacks. Forcings are factors that cause climate change, such as changes in solar radiation or greenhouse gas concentrations. Feedbacks are processes that can either amplify positive feedback or diminish negative feedback, the effects of these forcings. Climate sensitivity. This refers to how much the Earth's temperature will change in response to a doubling of atmospheric carbon dioxide. It's a key parameter in climate models and projections. Tipping points. These are thresholds in the climate system that, when crossed, can lead to large and often irreversible changes. Examples include the melting of major ice sheets or the dieback of the Amazon rainforest. One of the most powerful tools in climate science is climate modeling. These complex computer simulations attempt to represent the various components and processes of the Earth's climate system. They're used to study past climate changes, understand current climate dynamics, and project future climate scenarios. Climate models have become increasingly sophisticated over the years, incorporating more components and processes. However, it's important to note that, while they're incredibly useful, they're not perfect predictors of the future. They provide a range of possible scenarios based on our current understanding and different potential futures. Now, let's address the elephant in the room: climate change. The evidence for human-induced climate change is overwhelming. Multiple lines of evidence, including temperature records, sea level rise, ocean acidification, and changes in extreme weather events, all point to a rapidly changing climate. The primary driver of current climate change is the increase in greenhouse gases, particularly carbon dioxide, due to human activities like burning fossil fuels and deforestation. Since the Industrial Revolution, atmospheric CO2 levels have risen from about 280 parts per million to over 410 parts per million today, a level not seen in at least 800,000 years. The impacts of climate change are far-reaching and include rising global temperatures, more frequent and intense heat waves, changes in precipitation patterns, leading to more droughts in some areas and floods in others, sea level rise due to melting ice and thermal expansion of oceans, ocean acidification, threatening marine ecosystems, shifts in plant and animal ranges, increased frequency and intensity of some types of extreme weather events. Climate science isn't just about understanding these changes, it's also about finding solutions. This brings us to the concept of climate mitigation and adaptation. Mitigation involves reducing greenhouse gas emissions to limit the extent of future climate change. This can include transitioning to renewable energy sources, improving energy efficiency, and protecting and restoring natural carbon sinks like forests. Adaptation, on the other hand, involves adjusting to the changes that are already happening or are projected to occur. This might include building seawalls to protect against rising sea levels, developing drought-resistant crops, or improving early warning systems for extreme weather events. As we look to the future, climate science continues to evolve. New technologies like satellite observations and improved computer modeling are enhancing our understanding of the climate system. Scientists are also exploring potential technological solutions to climate change, such as carbon capture and storage or solar radiation management, though these come with their own sets of challenges and potential risks. One exciting area of research is paleoclimatology, the study of past climates. By analyzing ice cores, tree rings, sediment layers, and other natural records, scientists can reconstruct climate conditions from thousands or even millions of years ago. This helps us understand how Earth's climate has changed in the past and provides context for current changes. Another frontier in climate science is the study of climate impacts on human systems. This interdisciplinary field combines climate science with social sciences to understand how climate change affects areas like agriculture, human health, economic systems, and social structures. As we conclude our journey through climate science, it's clear that this field is not just about understanding Earth systems. It's about shaping our planet's future. The challenges are immense, but so too are the opportunities for innovation and positive change. Climate science reminds us of the interconnectedness of all Earth systems and, by extension, all life on this planet. It underscores the profound impact human activities can have on global systems and challenges us to think and act on a planetary scale. As we face the realities of a changing climate, the knowledge and insights provided by climate science will be crucial in guiding our decisions and actions. Whether it's informing policy decisions, driving technological innovations, or inspiring individual and collective action, climate science plays a vital role in charting our path forward. In the words of the famous naturalist David Attenborough, the truth is, the natural world is changing, and we are totally dependent on that world. It provides our food, water, and air. It is the most precious thing we have, and we need to defend it. As we end this episode of Sci Discovery Chronicles, we hope you've gained a deeper appreciation for the complexity and importance of climate science. Remember, every one of us has a role to play in understanding and addressing the challenges of climate change. Until next time, keep exploring, keep questioning, and keep discovering the wonders of science. YouTube description 197 words. Join Sci Discovery Chronicles as we unravel the complexities of climate science in our latest episode. From the intricate interactions of Earth's climate systems to the cutting-edge research shaping our understanding of global change, this video offers a comprehensive look at one of the most crucial scientific fields of our time. We explore the key components of the climate system, delve into fundamental concepts like the greenhouse effect and carbon cycle, and examine the powerful tools scientists use to study and predict climate patterns. The video also addresses the pressing issue of climate change, its impacts, and the ongoing efforts in mitigation and adaptation. Whether you're a science enthusiast or simply curious about the world around you, this episode provides valuable insights into the science that's shaping our planet's future. Discover the fascinating world of climate science and understand why it's more relevant than ever in today's rapidly changing world. Don't forget to like, subscribe, and share to join us on our journey through the wonders of science.